As promised, I'm just going to quickly do this question for you again I was getting sidetracked by the book. We're going to just do it from base principles and make sure that we're getting it right. So the free body diagram, I've put in those arrows already. So it was the normal force going that way. We can put that just in again quickly. That's F normal, and then this was our Fg. That was the free body diagram. Then they asked us to write the expression of the centripetal force. Now remember what we said, if you were going to do that little triangle that you are used to in core physics, the triangle would be here, so that would be the angle, and corresponding you can prove these two triangles similar. But you don't need to do that in further physics, but it should be easy-ish for you to do that. So then we can say, okay, if we look at this upward force there, I should actually use a different color. So if we're looking at that upward force there, because there is no movement in the vertical direction, these two forces should cancel each other out. So this is going to be F normal vertical. I would not call it Y because it's not your perpendicular component, but I'm sure it won't be marked wrong. And then this one here will be F normal horizontal. Now if we look at the trig, this angle here is going to be our 40-degree angle, and that means this one is adjacent. So the normal, the vertical one is going to be cos. So this will be F normal cos 40, and that one there will be F normal sine 40. Okay, so then it's pretty easy, because then we can say, fine, I've got my upward force and my downward force being equal, and they did ask us that in the third question here, to write the normal force in terms of the weight of the car. So we can say that F normal times by cos 40 is equal to Fg, and then we can say that F normal is going to be equal to Fg is then mg over cos 40. Then we have that one. Then we can look at our horizontal forces. If I look at the forces in the horizontal direction, I've got my force going into the center of my circle, which is my centripetal force. I'm just going to call it Fc again. And then I've got my my horizontal force there that I have there at the top. So I can say Fc is then caused by that horizontal force. So those two are equal. It's causing the inward acceleration. So I can say Fc is equal to F normal sine 40. There we go. Now we've got the centripetal force, we've got the normal force, and in the end they ask us for the distance that it should travel. Now remember, your equation has an r in it, so we're going to calculate the radius of our circle, and then we'll just double it to get the distance d, or we can just, that I will have to use with the triangle, because we're going to work out the radius of the circle, so we're going to get this, and then we need to do the trigonometry there to do that. But once we have that, the maths is easy for you. So now, to get my centripetal force, you can go to your information sheet. I just snipped it here for us quickly. So if you look at your information sheet, we've got that. We want r. So we're going to use this equation with the v squared over r, because they actually gave us the speed. So it's logical to then go and use that equation rather than anything with angular velocity in it. So we're going to say that v, this is going to be, that's a, so I have to add the m for f equals ma. So mv squared over r is then going to be equal to f normal sine 40. So f normal sine 40. So it's a bit of maths now, so we're going to just put this normal force in there, and we're going to get mg over cos 40 times by sine 40, and you can simplify the maths there and say that sine 40 over cos 40 is going to give us tan 40. the m's cancel out. And that means that we now can change our equation. I'm just going to do it on this side so that I have more space. I can change my equation to say r is then equal to v squared over g times by tan 40 degrees. And now we can go and put our values in. So that's going to be our 34 that's given in the question squared. G is going to be 9,81 times by, I even forgot the 0 there, and that is tan 40 degrees. So that means if you do that on your calculator, let me quickly do that. I got an answer of 140,435. Remember, it's not your final answer, so don't go and round it off too much. You actually didn't even have to write that one down. You could have left it in your calculator. And then if I times that by 2, you can please go and check my maths, because I'm doing this pretty fast now. So then to get D, I'm just going to say that's going to be that 140,435 times 2, which is, if I keep that value in the calculator, I'm going to get 280. So that means it's not that written down value, 280,86995, so 996. And then we need to go and look at how we're actually going to give this, because our significant figures then matters. And we can see that the speed was given to 3 significant figures. We cannot use the angle, because that's an absolute angle there. So we're going to use 3 significant figures, which means I will then round this off to 281 meters, which is definitely a way more realistic answer than what we got last time.